The James Webb Space Telescope, the most extraordinary telescope that's ever been built, and its data is actually available for the general public to use once it's been processed and used by the professional teams actually using the telescope. Behind that huge reflector, we have quite a few different instruments. The first thing is to figure out what are we after, what data do we need from what instrument. And we got the MIRI, we got the FGS, we got the NORCAM, we got the NORSPEC. So let's have a look at the different wavelengths that are recording. So we can straight away rule out the spectroscopy because it's not really what we're after. We're after the imaging data that we can use. And the NORCAM sits in the best place. In this view, you have wavelengths in micrometers. So if you translate that into nanometers, the NORCAM is capable of recording from 600 nanometers to 5,000 nanometers. And 600 nanometers is smack in the middle of the spectrum of the visible light. So the NORCAM is the instrument that gets the closest to the kind of wavelengths that we would normally use in astrophotography. So it's the NORCAM we're after and the data from it. So what does it look like? Well, here we are. This is a pretty impressive piece of equipment, and I can assure you I would not be able to afford one if I wanted one. So let's go and see what data this wonderful device have produced. So the best site to get the data from is the mast.stci.edu, the search page. I'll provide the link in the description below. Firstly, select mission, we're going for JWST. That brings us to the search screen. So the first thing is that we're after images. So let's untick spectrum, time series and others. When it comes to instruments, we want the NORCAM. So let's untick everything else. We also just need to say that we want the, well, NORCAM image. And then we want to make sure that we're just looking for the public stuff. So in here, we want to add a filter, status, and the condition here will be public. And that's all we need before we search for the object. And in this case, it is NGC 3132 with the 8-burst planetary nebula. And the nice thing is that it looks it up in SIMBAD, so you know when you typed it, it's actually something that matched and something that it's actively searching for, as you can see at the bottom here. So you don't have to worry about typos and stuff like that, because if it's resolved in SIMBAD, it will be a valid astronomical object. This takes a bit of time, so let me just jump on to the next screen. And indeed, here we have something. So we have a NGC 3132, which is exactly what we're after. Got exposure time of 1460. So let's tick that, and then we go to download. And in download, we do the quick download zip, and then we choose recommended files. That will select files that are of use to us. So that means that the download has started. So let's return when this is downloaded. It's now downloaded the file, and I've unpacked it, and in here we'll find the information we need. So don't worry, we only need the id2.fits. So that's the good news. The bad news is that if I drop one of these into PixInsight, we have loads of files. What to do? Don't worry. So effectively, SCI is the file which has been calibrated, registered, and stacked. All the other ones have been used to achieve this. So we can do this, 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 and this. Let's give it a bit of a stretch. And there we go. The first image. It looks horrible, but bear with me, there's more. So as you saw before, we do have the other files as well. Let's just unpack them one by one. Here are the 6 images that's been unpacked, the SCI ones, and I named them in according to the filter. It's worth noticing that they are roughly aligned, but maybe not entirely, and we also got the bottom ones that are roughly twice the size as the top ones. Each of these filters represent a bandwidth, a frequency of light, and we want to map them to R, G, and B in order to make a color image. So which one goes where? And I have to admit, I actually asked ChatGPT. What I have here is a diagram with the different filters and where they fit into the spectrum. We got 4 red candidates. Let's just have a look at what we have here. 444 and 405 is these first 2 here. And for me, it's obvious that 444 wins out of those 2. But then we've also got 212N and F187N. And 212 is definitely better. Some stacking artifacts, but better. And it's also twice the resolution as 444. But I'm actually going to stick with 444 for this processing. Then we only got really one green candidate, and the green candidate is the F365W, and that looks good to me. And the blue one, F090, is down in the corner, and yeah, that looks quite good to me as well. Those are the candidates that we're going to combine together into an RGB image. These are almost aligned, but as you might be able to see at the bottom of the screen down here, you can see that there are slight differences. Firstly, register these. So we're going to do a star alignment, and we're going to use 444 as the reference, and then we're going to pop the other 2 in here, and then we'll run that. I'm going to use again the 444 as the reference image, and what I'm going to do is that I'm going to do a dynamic crop on this one. As I know there's some stacking artifacts at the edges here, but I still want to grab as much as possible, so I'm going to be quite generous. Maybe not here, but it's not too many details, but I might push this a bit further. Let's make sure that we do a crop for these 2 and this one. And then we need to go in and process, and we need to do a channel combination. And the channel combination is going to be 444 is going to be the red, and the 365 is going to be the green, and then finally the 090 is going to be the blue. And then we'll just combine those together, and ladies and gentlemen, here we are. Oh, sorry, I should have done it unstretched. Sorry, unlinked. I know it looks horrible, but just wait. You need to remember that we're doing this with false colors. The frequencies of the light that we are actually combining together into an RGB has nothing to do with the actual RGB colors as such. It's completely different wavelengths. Something I forgot to mention before is that if you look here, you see pretty extraordinary odd artifacts in the middle of the the stars. That's actually chronography. No, it's called coronography. We actually cover the most intense parts of an image in order to make sure that it actually doesn't outshine everything else. If you look at the amount of details already, and I've done nothing. If I got this on my telescope, I would probably be unconscious on the floor. Then I would start with the blur exterminator. When it comes to sharpen the stars, I'm going to drop it down to 0.30. I might actually want to extend the halos just a tiny bit, and I want maximum. I mean, it's fantastic data, but I still want to put it at 1 and just see. So let's see what that looks like. That looks pretty good without and with. So it does. It's amazing data, but blur exterminator is just having the convolution really helps a lot, even with the structure inside and so on. Yep, let's go with that. So that's where we're at now. And I mean, when I'm looking at my images, I normally don't see anything like this, that's for sure. So I'm going to do another dynamic crop to get rid of some of the artifacts introduced by the blur exterminator. And then within the linear state, it needs to be stretched, and I'm going to use my favorite script from Setiastro, which is the statistical stretch. And I'm not going to do a linked stretch because we are not doing natural colors here. So let's see what the preview is with 0.25. And oh God, I can't help this. This data is just beyond belief. So I'm just thinking that maybe I should add just a tiny bit of additional stretch to it. Yeah, that looks nice. I might actually bump that up a tiny bit as well. And yeah, that's nice. That's nice. So let's run that. Awesome. And here we've got a new picture. It's very green, but we'll get to that. And after a stretch, I normally like to see if I can reduce the black point a bit. So first, let's have a preview. And then I'm going to switch to linear. And I don't think the low clip is going to... No. So we start with 1 straight away. So I am clipping a bit. But as you can see, that clipping. The thing is that there are some, very minor artifacts in the background. But if I just drop the black point a bit, it looks so much better, and a lot of the distracting noise in the background goes away. So I think it's definitely worth it. And I mean, I'm losing very little data. So that's what I'm going to go with. And that's the image we got now. Let's try an SCNR. So if we do 1 straight away, yeah, let's let me just check if I do 1, which is 0.5, we get more interesting color. I might try 0.75. I'm gonna stick with that level. Normally at this point I would do noise exterminator, but I just want to show you something. 3 maximum, and then let's do a preview. Okay, so here's the image that has been processed with noise exterminator on like maximum and everything. So let's zoom in a bit, and I'm now going to switch off the enhancement. Did you notice it? Neither did I. Sorry about that little distraction. So yeah, I would then like to do some local histogram equalization, which is contrast for normal people. For PixInsight people, that's the full name. Let's do a preview here and see what we can do. So we are at 50 now. Let me just pop this up to 1.8, I think, and see what happens. Yeah, a tad of a difference. And then if I do, instead of 50, I do 150. Yeah, that looks a bit better. But I think it's a bit, I don't know, it's a bit too much, I think, because I want to be really careful with this amazing data. So that's a bit blurry and everything. And that's, I'm not sure. Let me put these to like 200 just to see the differences. I don't know. I might put it at 300. I put it at 400. Let's zoom out and see and make sure that we're happy with that. I mean, it's, yeah. No, I'm gonna go with that. I'm gonna go with 400. That's without and calculating. This is with. I think, yeah, no, I think that looks really good. Let's do some curves transformation as well. Reset everything, and we'll start a bit with the RGBK, and I think if I have a preview and look around, it's all happening all the way down here. Yeah, so I'm going to set my pivot point quite low. I'm going to pop it down here, and then we want to do some reduction to get a bit darker and a bit more contrast. Oh, that's nice. That's nice. That's yep. No, that's almost too much. That's almost too much. I think I'm going to pull it back a bit. Before, after. Before, after. Yep, that's definitely enough. I might even go in at the top here and just say calm down a bit. Yep. Let's just add some prominence and see what happens. I'm going to lift that up a tiny bit. Oh, wow. It's way too much. But that's pretty nice. So without, with. Oh yeah, no, that's nice. And that's enough. I would normally have another 10 steps to do, but to be honest, just look at this. It's just insane. So the last part is really going to be in Affinity Photo to just retouch a few things and so on. This video is quite long already, so I'm not going to go through the Affinity Photo 2 workflow. It's roughly based on a workflow that's been developed by a YouTuber called SkyStory. I linked that below. And if people are interested in what I did in Affinity Photo 2, then yeah, let me know in the comments, and I can do a separate video of that. I've done a frequency separation, so low and high frequency, because I'm doing different things on each. So with the high frequency, some levels adjustments, the clarity and the unsharp mask, so makes a bit of a difference, not massive. And then the low frequency, I've done the levels adjustment, and that have a bit more of an impact on their overall color and appearance. Then I got to global corrections as well, and that's the vibrance and saturation and some curves. And that gives a bit of oomph to the image. The only other thing I've done is I've gone in with a in-paint healing tool and just removed the artifact in the middle of the stars. And this is the finished image, and this is what I uploaded to Astrobin, and that's the final result. It's been fantastic to work with data like this, and the result with just a light touch is quite extraordinary.